So it's Algebra 1 again, and we're moving on to more complicated equations. And our equations this time are going to have our letters or our variables on both sides of the equation. Now, our number one goal when we're doing this is to get we only want one letter. And so if we have a letter on one side and a letter on the other side, we're going to have to add or subtract to move one of them to the other side. And so we're always looking to this move or collect to the one side of the equation. And my goal is to always try and end up with a positive coefficient. I'm a former negative dropper. I have issues with negatives. And so I try and look to make my coefficient positive. Some people really like to keep their variable on the left-hand side. So it's just what they're used to seeing and they know how to work. Both methods are absolutely correct. And you'll find people solving equations in different ways that are still totally mathematically correct and will give you the same answer. And so that's why we're constantly looking at how did you do this to make sure your solving method is sound. Because there are lots of different ways. And we don't want to have to teach you one way and this is the only way, and I don't care if your parents did it a different way, you have to do it my way or the highway. That's not how this works. We want you to be successful, so your brain may work a better one way than the way my brain works. And that's okay. We need to find what works for you and get you to where you need to be. And that's the ultimate idea here. So we're going to use a lot of the same properties we were just using. We're going to draw our line to indicate our two sides. And this is how we can tell the difference between our combining like terms problems and our variables on both sides. By drawing our line, I see that my n term here and here are on different sides, which means I can't just do a 7n plus a 5n. Because they're on different sides, I have to use inverse operations. So if they're positive, I'm going to have to subtract. If they're negative, I'm going to have to add to move it to the other side so they can combine to become just one variable term. And so what I'm going to do is I'm going to go ahead and I'm going to move my smaller coefficient. And so smaller coefficient is that number in front of the variable. So if I'm looking at my 7n and my 5n, 5 is smaller, so I'm going to move that one. And I use that, so again, I have that positive coefficient. Positive number in front. And that's my goal. So if this is a positive 5n, to make this go away, I would have to minus 5n here. And to keep it balanced, I have to minus 5n here. Now I line it up under the n's because they're like terms, and that's how I can make that work out. I'm not accidentally adding apples and oranges. I'm adding apples and apples, or n's and n's. So here this becomes 0, so now there's no n on that side. A 7n minus 5n gives me 2n. I still have this minus 2, and over here I still have this positive 6. And I keep that sign right here, so that stays positive. And now I'm just back to my two-step equation. So I add 2 to both sides. So now I have 2n equals 8. I divide by 2 on both sides. And so now I have n equals 4. And that's it. So on my next one, I kind of threw you for a loop because now all of a sudden we have decimals. So I wanted to remind you, what do we do when we have a bunch of decimals? So I could still draw my line to start off with, but with decimals, I count how many decimals I have. So I have 1 decimal here, 1 decimal here, 1 decimal here, 1 decimal here. When I have 1 decimal, I times everything by 10. So I times by 10, which is really telling me that I'm allowed to move my decimal 1 spot to the right. So this number now becomes 5. This now becomes 3y. This now becomes 7y. This now becomes minus 3. And so now here's where you'll get the difference between wanting everything on the left-hand side or wanting a positive coefficient. Since I want a positive coefficient, what I'm going to move is 3y. But if you want everything on the left side, you're going to want to move the 7y. If I move the 7y, I would minus 7y on both sides, but I'd end up with a negative 4. because I like positive numbers, I prefer to move the 3y. Since it's a plus 3y, I minus 3y on both sides. 3y minus 3y becomes 0, so now I'm left with this positive 5. And this is now a 4y minus 3. Now I'm used to solving equations that look like this, but if some people do this and they still want the positive, you can flip-flop this. And if you want to flip-flop it, it would look like this. 4y minus 3 on this side of the equal, and 5 on that side. And you could solve it like this. And that's fine. You can do the flip-flop. But do the flip-flop so it looks, this side here will look exactly the same right here. And it just makes it more sound math, so you don't accidentally move a sign when you shouldn't have. Okay, so from here, if this is my y variable, right here, I'm going to move everything away from it. So I'm going to move the minus 3 first by adding 3 to both sides. So a minus 3 and a plus 3 becomes 0. 5 plus 3 is 8, and that's equal to 4y. Now I'm still looking at getting rid of whatever is with this y. So I'm getting rid of that 4. Now since they're side by side, that indicates multiplication. To undo multiplication, I divide. So 4 divided by 4 is 1. 8 divided by 4 is 2. So I get 2 is equal to y, which is the exact same thing as saying y is equal to 2. Just because it's flip-flop doesn't make it wrong. But again, we're always looking at how does your brain work the best. We want to make sure that your math is solid, you feel comfortable, and you are successful with this. So if you need to do the flip-flop early, like right here, do the flip-flop early, that's fine. If you don't need to, then don't. Work it out like this. Okay, so let's move on to the next one. Oh, there we go. So this one's a little funky because when we're looking, on this side I only have a 3b. So I'm going to work out these two problems. The first one I'm going to do one way, the second one I'm going to do the other way. So the first one, I'm going to go ahead and work out my normal method. I'm going to take the smaller b and I'm going to move it. So if this is 3b, I'm going to minus 3b from both sides. So now 4b minus 3b becomes 1b. And here, 3b minus 3b would cancel out. When it cancels out, it's leaving nothing behind. What number represents nothing? That would be the number 0. And so now I just have a simple two-step equation. Now we can even take it a step further. 1b is really the same thing as b. So I could really write this as b plus 2 is equal to 0. And then I move everything away from the b. The only thing with b is plus 2, so I minus 2 on both sides. And b is equal to negative 2. So that's one of your options. Your other option is to go ahead and just move the bigger number and end up with a negative coefficient. It's fine. It is always an option for you. So because this 4y is by itself, I'm going to move this 7y over. So I'm going to minus 7y on both sides. Now when I'm minusing 7y, I'm going to end up with a negative 3y. Because again, I'm just adding and subtracting those front numbers, those coefficients. So I end up with this negative 3y. Now over here, I have left a minus 15. So when I come down here, I don't want to forget that negative. So now from here, I have a negative 3 right next to a y. And when they're side by side, that indicates multiplication. So to undo multiplication, I divide. The 3's cancel, the negatives cancel, and I'm left with y. 15 divided by 3 is 5. The negatives cancel, so my answer is positive. And that's it. So what's nice about the second method is it's less writing. What's bad about the second method is you end up with a negative coefficient. And so if you have issues with negatives, it can cause a problem. You've got to figure out where your strengths lie and choose the appropriate method. Both will give you the correct answer. Okay, so again, more complicated problems because we just keep on pushing you. So we draw our line to indicate our two sides. And if we have more than two terms on one side, or if we have parentheses on a side, we have to take care of that. We always look to get rid of parentheses first, and second is combining like terms, and then we're back to what we were doing before. So my first problem, I've got parentheses, so I'm looking to distribute. So 4 times 2x, and 4 times minus 5. So 4 times 2x gives me 8x, 4 times minus 5 gives me minus 20. On this side, I have 5x plus 4. Now I'm back to where I was. X is on both sides. You pick which x you want to move. I'm moving the 5x because it's smaller, so I'm minus 5x on both sides. Again, lining up those x's so I make sure I'm combining the right terms. So 8x minus 5x gives me 3x minus 20 equals, now this is all gone, so all I have left is a positive 4. Two-step equation, move the minus 20. So now this turns to 0 and goes away. I'm left with 3x. I have 24 on the other side when I combine. Now these are side by side, it's multiplication, so I divide. So now I have x equals 8. So on our next one, woohoo, we've got all sorts of stuff going on. We've got a lot of stuff on the left-hand side, and on the right-hand side we have parentheses. So I'm going to go ahead and I'm going to look at what can I combine on the left-hand side. So I've got the 3x, a plus 15, and a minus 9. These are both constants and can combine. So I'm looking at that plus 15 minus 9, which gives me a positive 6. So that's what that side looks like. Now on the other side, I'm going to go ahead and get rid of the parentheses. So I'm going to multiply in by 2 to both terms, because I have two groups of each. So 2x's give me 2x, and 2 2's gives me 4. And now I'm ready to go ahead and move my x's to the same side. I'm going to move the smaller x term. Again, I'm making sure I line up the x's together. 3x minus 2x is 1x, and 1x is the same thing as x. So this is x, this plus 6 comes down, and I'm left with a positive 4 on this side. From here, I'm moving everything away from that x, starting with that plus 6, so I minus 6 on both sides. So now I have x equals negative 2, because 4 minus 6 gives me negative 2. Okay. At any point in time, if you feel like you need to pause and just take time to write, that's fine. It's always good to just listen and watch, then pause and write. So again, always thinking about what's best for your brain, what's best to help you learn. Rewind, watch again. Always an option for you. Okay, so wow, we just keep getting more and more complicated here. So I'm going to draw my line, indicate my two sides. If I've got parentheses, I get rid of those first. So on this side, I have a minus 7 that I'm distributing inside. On this side, I have a minus 3 that I'm distributing inside. Whew. So I leave the 6 out here, and I distribute it in the minus 7. So minus 7 times a is minus 7a. Minus 7 times 1 is minus 7. On this side, minus 3 times 2 is minus 6. A minus 3 times minus a. So negative times negative gives me positive 3a. So my right-hand side's good. I've got an a term, I've got a constant, but on the other side, the left-hand side, I've got a 6, and I've got a minus 7. They're both constants, they have to combine. So 6 minus 7 would give me negative 1. Now I still have this minus 7a, so I'm going to bring that down. And now I'm looking at my a's and I'm thinking, what's my smallest number? Well, 3 is the smallest number when you're looking at just number, not signs. But the 7's negative. So I'm going to move the negative number because, again, I don't want negatives. I'm going to try and get positives. So if I'm going to move that negative 7a to turn that into 0, I'm going to add 7a, because again, I'm looking at doing that opposite. So I add 7a on both sides. Again, lining up those a's, so that way I know this turns into 0. I'm left with a negative 1 on this side, a negative 6, and this is a positive 10. And again, you can flip-flop if you want to. You can do what you need. But the idea is, here's my a. I want to move everything away from it. And I start with the number that's not right next to my a. So that negative 6 I'm going to move by adding 6 to both sides. So that turns into 0. This turns into 5. So 5 is equal to 10a. And they're side by side, so that's times. So to undo times, I divide. 10 divided by 10 becomes 1, so I have that 1a, which is really just a. 5 divided by 10, I can reduce by dividing the top and bottom by 5. I can go ahead and do 5 divided by 10, and I would get 1/2, or if you use the calculator and got a decimal, 0.5. Okay, so for our next one, I draw my line. I've got a mess on my left-hand side. And on my right, I even have more of a mess. So I'm going to go ahead and I'm going to look at that left-hand side and I'm going to combine what I can. So I've got a negative 6a and a positive 4a. And this 4 is just hanging out here. So a negative 6 plus 4 would give me a negative 2a. That's simplified. Now on this side, I have to get rid of the parentheses. So I have to distribute. So I'm distributing in not just a 5, but the minus 5, because that minus belongs to the 5. So the negative 1's hanging out. Negative 5 times 7 is a negative 35. Negative 5 times negative 2a gives me positive 10a, because negative times negative is positive. And I'm still messy on the right-hand side. I still got a lot going on. So I've got a negative 1, a negative 35 being added together becomes negative 36. So I combine those like terms. Now I know that's being like added together, or you could do a fancy subtraction, not at times, because there's no parentheses there. There's nothing indicating those numbers are being multiplied. So negative 1 minus 35, or you could look at it as a negative 1 plus negative 35 by doing your add a line, change the sign. And that's really what I was doing without formally writing it out. So now I'm looking at my a's, trying to decide what to move. I'm going to move the negative 1. So this is a negative 2a. So I'm going to add 2a to both sides. So now I have 4 equals negative 36 plus 12a. Now because my a is right here, I'm moving everything away from it. Starting with the regular number, not the one that's right beside the a. So my regular number is negative 36. So to move it, I add 36 to both sides. So this becomes 0, this becomes 40. I still have this 12a. Side by side indicates multiplication, so I divide. Okay, it's not going to be a pretty answer. So I'm going to go ahead and simplify the fraction by dividing by 4 on top and bottom. So 40 divided by 4 is 10. And I'm kind of writing this backwards because of where I have room. And 12 divided by 4 is 3. And that's my answer, 10 over 3. Again, you could turn it into a decimal if you want. Using a calculator, that's just fine. So now that we've worked those out, started simple, went more and more complicated, lots of examples to give you. So as we're working in class, you should have your notes right there to always reference back to help remind you, oh, what do I do next? Oh, there's my notes. There, let's look at it. Okay. So now we're going to look at some word problems. So let me grab the highlighter here. A painting company charges $2.50, so this is my initial price, kind of like what we talked about before. And then they charge you $16 an hour. So that's our rate. So when I'm setting this up, I'm going to take that initial cost. I'm going to add in the rate times whatever I'm doing it per. So if this is $16 per hour, I'm going to go ahead and put an H here for every hour. But now we have a different painting company. So what I'm going to do here is this is going to be equal to whatever's going on with the other company. So this other painting company charges $210 and $18 an hour. So when I'm looking at this, my initial price plus $18 an hour. So rate with my H and my initial price by itself. Now, how long is a job? How long is a job for which the cost for the two companies are the same? Now, this being the same, that's what tells me that these should be equal. And because I kind of knew beforehand, I kind of put the equal sign in there. So I want the prices to end up being the same. So how long would it take for those prices to be the same? And we're not going to solve that. It says just set up the equation. This is where it really pays to read the directions. When it says set up the equation, that's all you have to do. You don't have to work it out. So always look for those. Doesn't always happen, rarely does. Okay, so next one. John and Sarah are planting tulip bulbs. John has already planted 60 bulbs. And he's planting at a rate of 44 bulbs per hour. So when we're looking at John, he's done 60 already, and he's planting 44 every additional hour that he works. Now Sarah, I'm going to go to her next. She's already planted 96. Pretty good. But she's only doing it at a rate of 32 bulbs per hour. So she has 96 to start off with and is adding 32 for every hour that she works. And how many hours will John and Sarah have planted the same number? So we're back to that same number of bulbs. So if we want those to be the same, we set them equal. Now, the next part is, how many bulbs will that be? So when I'm solving for H, but H represents hours. If you want to know how many bulbs it is, you would have to take this H and plug it into 60 plus 44 times whatever that number is that you get for H. So you'd have to solve the equation and then plug it back in to figure out how many bulbs it was for each person. And so again, this is a lot of foreshadowing to something we're going to be doing in chapter 5.